In today's lesson, we are solving equations like we've done before, but with the exponent 2. These are called quadratic equations because the highest degree is a 2. Okay, so we call these quadratic. Don't ask me where that term comes from, but it's one you'll hear in math frequently. So solving a quadratic equation starts like you would if it was not quadratic. We use the inverse or opposite operation to undo the plus 7, so that I just have the monomial 2x squared over here and 18 over here. Now what do you want to do? Let's use the inverse of multiply, so I can get rid of the 2. We divided by 2 to get 9. This one works out pretty nicely. If I have a squared, to undo exponent, I use a square root. Square root. Square root of 9 is nice. It's just 3. Now, isn't it true that not only positive 3 satisfies the equation, but also negative 3? Because negative 3 times negative 3 is also 9. Positive 9. We can check by putting negative 3 in here for x, and that will work. Let's try this problem. Okay, we pick up kind of where we were here, dividing by 2, getting me x squared equals 8. Doesn't work as neatly as 9 did. I'm going to end up square rooting this and realizing that it dissolves my 2 away, my exponent 2, but then I've got square root of 8. Are we done? No, let's take, because 8 is really worth square root of 4 times square root of 2. So this is 2, and this is times square root of 2. That's a full credit answer. Otherwise, this would be minus half, because it's not reduced, just like a fraction needs to be reduced. If you get a proportion problem, remember we solve proportions by cross multiplying. When you have an x on the bottom and an x on the top, you end up with an x squared, and that's why these problems have something to do with less than 93. So we square root, giving us x equals square root of 6 cannot be simplified. How about Jamie making a mosaic? Get rid of all of this so we can focus our attention here today. He's using 100 1-inch square tiles. If the shape is to be square, that's nice, but how long should each side be? Remember the formula, because he's using area. Area is for a square, side squared. Okay, now that we have our formula written down, 100 1-inch square tiles means his area is 100. They want to know length of a side, which is represented by S. How do I solve? I get rid of this by square rooting, right? S then simplifies to 10. How long would each be? You'd have 10 on each side, which is, when you think about it, a pretty easy problem, but we're using new stuff to answer that. So I want you to solve and check 3 of these. Maybe pick a nice variety so that you don't just do 3 of the same kind. Now is the time to practice and get better.